Good morning, everyone. Welcome back. Thanks for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yeah, and this morning we're talking about our favorite space telescope. That would be the James Webb, and how it has found a hidden planet, a giant hidden planet, actually. So here we go.
Here we go. James Webb Space Telescope has found a hidden giant planet by detecting its atmospheric chemistry through a bright debris disk. For years, a third giant planet remained concealed within the bright dust surrounding Beta Pictoris, one of the most closely observed planetary systems in the Milky Way. NASA's James Webb Space Telescope has now exposed the hidden world by detecting molecules in its atmosphere. That's what it normally does. Would you like to know more?
The young star was already known to host Beta Pictoris b, one of the earliest exoplanets captured through direct imaging, and Beta Pictoris c. The addition of Beta Pictoris d makes Beta Pictoris only the second known system with at least 3 imaged planets. Unlike its 2 companions, the new planet was initially recognized through its atmospheric chemical signature rather than a distinct point of light, demonstrating a potentially valuable way to other difficult to see worlds, to find other difficult to see worlds.
So let's say that you're in Beta Pictoris D, you're on that planet, and you've got a James Webb Space Telescope in orbit trying to look at us and trying to find Neptune. Neptune is way out there, right? And it takes many hundreds of months to transit around the sun, and it's there just for a little bit. You'd have to be lined up perfectly where you are in Beta Pictoris to see that. If it's crossing down here, you're not going to see it. So that's why they're only picking up the first, the second, maybe the third planet from the sun, because it's closest. It's pretty interesting.
Yeah.
All right, here's a quote.
They're on it all the time, right? Or somebody's watching, somebody or something is watching this all the time.
Yep. Quote, "This discovery adds another piece to an already fascinating planetary system," said Aidan Gibbs, lead author of a new study published in the astrophysical journal Letters on July 15, 2026, and a postdoctoral researcher at the University of California, San Diego. Beta Pictoris has long served as a laboratory for understanding how planetary systems form, evolve, and now we have another planet helping us tell that story.
Beta Pictoris lies 63 light years from Earth and is approximately 23 million years old. Its relative youth and proximity allow astronomers to examine how newly formed planets interact with the remaining disk of dust and debris from the system's formation. And that would be on the slide that just came up.
Yeah, and it's interesting how, we talked about this, but here, this is how these scientists are picking this up. And you can see on the left there, the planet transiting and orbiting their sun, and these radio waves is what they're picking up. So fascinating. Research estimate that Beta Pictoris d has at least twice Jupiter's mass, making it the least massive of the system's 3 known giant planets. Models place its orbit about 30 astronomical units from the star. That's an astronomical unit is the unit of Earth to our sun. So 30 of those distances from its star, similar to Neptune's position in our solar system. It follows the widest orbit of the 3 planets, but remains inside the debris disk's inner boundary.
The researchers did not set out to find another planet. They were using Webb's NIR spec, or near infrared spectrograph, to examine the atmosphere of Beta Pictoris b when evidence of Beta Pictoris d, as in David, appeared. The observation relied on NIRSpec's integral field unit, which records an image while collecting a spectrum from every pixel.
Where reflected light from dust should have produced a smooth spectrum, the researchers instead saw repeated peaks and dips. The pattern came from carbon monoxide absorption lines, arranged like a barcode and characteristic of the atmospheres of giant planets.
Spectroscopy can reveal both an object's chemical makeup and its movement. By measuring radial velocity, the researchers determined that the source's speed, location, and alignment with the debris disk matched an object orbiting Beta Pictoris. The evidence did not fit a distant background star or a brown dwarf containing carbon monoxide.
Follow-up observations obtained through a director's discretionary time request used Webb's MIRI mid-infrared instrument to detect methane and water vapor. These molecules provided additional confirmation that the object was a planet and revealed more about its atmosphere. Let me advance the slide here. There we go.
Okay, so because the planet was identified spectroscopically, astronomers could begin investigating its atmospheric properties during the same observation that revealed it. Quote, a spectrum contains an incredible amount of information, according to the author. You don't just learn that something is a planet. You immediately begin learning about its temperature, chemistry, and motion, unquote.
An independent imaging analysis led by Ben Sutliff of the University of Edinburgh and Marcus Bonse, not making that name up, B-O-N-S-E, of the European Southern Observatory supported the discovery. That work used observations from the European Southern Observatory's Very Large Telescope and Webb's NIRCam, Near Infrared Camera, to confirm Beta Pictoris D separately.
Beta Pictoris D avoided detection for so long because it lies within one of the brightest debris disks astronomers have observed. Dust scattered the star's light like fog, obscuring the difference between an actual planet and features within the disk. Webb's spectroscopic approach largely bypassed that confusion by isolating the narrow molecular signals produced by a planetary atmosphere.
The planet may also explain several unusual features of the disk, including its sharply defined inner boundary. Astronomers had previously proposed that an unseen planet resembling Beta Pictoris D could be shaping the disk into its observed structure.
The findings does not more than add another planet to the Beta Pictoris system. It demonstrates a new strategy for detecting exoplanets in environments where dust or other structures interfere with conventional imaging. Beta Pictoris D is the first directly imaged planet found primarily through moderate resolution spectroscopy. The results show that atmospheric fingerprints can reveal planets in visually complex systems without relying entirely on traditional coronographic imaging. No idea what that is.
The researchers will continue examining Webb's data to refine estimates of the planet's orbit, temperature, and atmospheric composition. Those measurements should provide a more complete picture of one of the best-known young planetary systems in astronomy. 61 light years, we could probably get there in our time, our children's time.
Yeah, so coronographic imaging, what is that, like a corona, is that like a sphere?
Corona is the thing around the sun. You know, when another body comes in front of the sun and the corona is all you can see.
Okay. Gotcha. Okay. All right, well, there you have it.
All right, folks, thanks for
James
joining
Webb.
us. We hope this was interesting.
Yep. We'll see you this afternoon. Thanks.